Okay, Algebra 2 classes. Yet another video. Yes, this is for Thursday, March the 26th. I goofed on Wednesday's video, the 25th, and I made one small error, which is not surprising given the type of day I've had today. My first day of remote teaching ever. Hope you guys are hanging in there. Okay, I goofed on yesterday's video, which would have been Wednesday's. Okay, I told you when I introduced you to what a Brock was, I said that all Brocks had to be greater than or equal to 0. That's not correct. It has to be greater than 0, not including, because Brocks cannot be 0 or negative. Okay, and this was your Brock. Remember, this is the guy, log base b of x equals y. This is what I'm talking about when I'm talking about the Brock. So any expression that's in here, you have to set it greater than or equal to 0, especially on inequalities. And you have to check any solutions that you got on equations and make sure that your Brock is not made negative. So all you have to do is plug your solutions in and see in the interval if it's an inequality or if it's just the solution itself in an equation. You got to plug it in and make sure this does not happen. So I apologize for that, but go ahead and make that correction. Make sure you know it is not greater than or equal to. It is simply greater than 0 on all Brocks. Okay, so let's start our lesson. All right, we're in 7.4, solving logarithmic equations and inequalities. Okay, we're going to start with the very basics, and then we're going to move through, increasing in complexity. Okay, so let me put my little microphone right there. Okay, make sure your volume's turned up so that you can hear me. Okay, I'll put this guy over here. All right, so we're going to start with chapter 7.4. Okay, solving logarithmic equations and inequalities. Okay, so when you go to your inequalities, you're going to have to use interval notation. Okay, because you're giving me a range of values. So I want interval notation, no excuses. Okay, on inequalities. Equations, you're going to give it to me in scrolls. Okay, the solution in scrolls. All right, let's start with the basic. Remember, I said these are my Rexes. They're my remote examples. So I call them Rexes. They remind me of T-Rex. Okay, Rex number 1, solve. Okay, remember, we've got to check our solutions. Check all solutions. All right, well, this is super basic. Okay, super basic here. So what you're telling me is okay, I got to solve for x in this one, right? We're going to solve for the Brock. All right, well, in order to do that, right now, it is sitting in log form. We need to put it in exponent form. Okay, so you're going to move it to exponent form. Okay, exponent form, which remember log breaks away. The base goes over here and pushes the exponent up. So we are left with x is equal to 36 to the 3/2 power. All right, well, from our rational exponent lessons, we know that this is the same thing. This is the root, right? This is the root, and this is the exponent. So basically what you're saying, x is equal to the square root of 36 to the 3rd power. All right, so we're going to say the square root of 36, right? The square root of 36 is 6, so x is equal to 6 to the 3rd power. And if I'm not mistaken, 6 to the 3rd power, I believe, gives us 216. Hang on. I'm pretty sure it's 216. But who knows at this stage of the game today? There's no telling what I might say. Yes, it's 216. Okay. So you solved and you said for this statement, log base 36 of 216 is equal to 3/2. In other words, 36 raised to the 3/2 power will equal 216. Well, that's correct. We just proved it. So x equals 216. 216 is not 0 and it's not negative, so we are good to go. So that's your Rex number 1, very, very basic. All right, I'm probably going to have to cut this video in half again because it's just going to take me that much time. Okay, next, we're going to start with Rex number 2. Okay, we're still solving some basic equations. I have Rex 2 and Rex 3. All right, let's look at this one. Right now, it's in log form. All right, remember how I taught you to shift from log form to exponent form? It's going to be beneficial depending on what your goal is and what you're given. So right now, it's log base 9 of x equals 3/2. Well, we can't do anything with it here. So we got to solve for x, which means get him by himself. So we're going to get rid of the word log. The base is going to move over, and he's going to bump that exponent up. So now we are looking at x, our Brock, is equal to the base 9 raised to the 3/2 power. Well, x is equal to, here's your root. So that's the same thing as saying the square root of 9, because that's my root, raised to the top power, which is 3. So that's going to be 3 to the 3rd power, which equals 27. All right, so your Brock, you just solved it as a value of 27. It is definitely greater than 0, so we're good to go there. All right, let's try another one. Same situation, we're solving for x, which is our Brock, so we have to isolate him. The only way to do that is to remove the word log, okay, and our base will come over and bump our exponent up out of the way. So we're going to be left with x on the left is equal to my base of 16 raised to a power of 5/2. Now guys, I don't want you to get used to using your calculators here. You guys know how to deal with these. Okay, you know that that's the root and that's the exponent in a rational exponent. So we have x is equal to the square root of 16 raised to the 5th power. Well, that means the square root of 16 is 4, and that's going to be raised to the 5th power. So 4 to the 5th is equal to 1024. Okay, so 1024 is the value of our Brock, and it is greater than 0, so we're in great shape. Okay, these are super easy. These are just like one level, level 1, I would say. Okay, now we're going to change gears and we're going to keep solving, but we're going to up the ante a little bit. Okay, so now we're going to solve, and you know logs is short for logarithms, on both sides of the equal sign. Okay, so that's what we're going to do. We're still solving. We must check our solutions. Okay. Solutions that don't work are called, you need to know this, I've already taught it to you before, extraneous, which means they don't fit. All right, they're false solutions. So you have to check for them. We did this with radical equations as well. So you got to make sure that your extraneous solutions are removed and you don't put them in the scrolls. Okay. Something else, when I say you got to check, for example, let's say you have log base b, some base, and let's just say your Brock looked like this. There's your Brock. And you're going to set it equal to something over here and you're going to solve. Well, you have to remember that this is your entire Brock. So you're going to have to make sure that whatever your solution is, that when you add 3 to it, it's got to be greater than 0. Okay? So we'll have to check it. So whatever you put in here, if it makes it, remember, cannot be, your Brock cannot be 0, and it cannot be negative. Okay, so when you have a variable involved in your Brock, you're going to have to make sure that you check this. All right, so there's just some heads ups. All right, I'm going to move to the next slide. Okay, now make a note of this. And again, you can pause this and go back and look at it and take your time in writing your notes. To solve equations with log expressions on both sides, and that means of the equal sign, this is what you're going to be looking at. Something log base b of a Brock A, is equal to log base b of Brock B. Notice I've highlighted the bases. These must be the same. If they're not the same, you cannot do what we're about to do, okay? You'd have to regroup and figure out another way, which we're not there yet. All right, so once you figure out the bases are the same, you can basically eliminate the word log and set each Brock equal to each other and then solve, because your variables are going to be in here. So it might be linear, It might be a quadratic, but either which way, once you've determined that this is the case, then block A and block B are set equal to each other, and that's when you're going to solve. Okay? All right, I am going to, let me pause this video, and I'm going to splice it right here, and I'll be back.